In today's lesson, we're going to be looking at how rates of reactions change over time, how we can measure it, and why they change over time. I'm Mr. Watts, this is What's Your Question, let's go! Okay, I've placed the objectives for today's lesson here, and they are to state how we measure the rate of a reaction, to describe how to calculate the rate of a reaction from a graph, and then explain why some different conditions can affect the rate of reaction as well. To start with then, there are three ways we can measure the rates of reaction, and I've recorded videos of each one of them ready for GCSE. First way to measure it is by timing the reaction, okay? In this video, I've set up a mixture of hydrochloric acid and sodium thiosulfate, and I'm timing the reaction to see how long it takes to change colour. Underneath these pots, I've put a black dark cross, and I'm starting the timer when I mix the two solutions. I'll stop the timer when the cross is no longer visible, and that'll be different for different people. The second way to measure the rate of a reaction is to measure the volume of gas given off over time. In this video, I am mixing together some hydrochloric acid and marble chips, and you can clearly see I've got the gas syringe set up to accept that gas as it's released. As the gas is given off, the gas syringe fills up, and we start our timer as soon as we mix together the marble chips and the hydrochloric acid, and we stop it when either we've gone over the end of the gas syringe or a reaction has finished, so no more gas is being released. And I'll write down the volume every sort of 10 seconds. It's really important that you give a time interval. So you could say 10 seconds, you could say 20 seconds. Just mention how often you'll make those measurements as well. The final way to measure the rate of reaction is to measure the mass lost during a reaction. This only works when gases are being released, like in our previous reaction between marble chips and hydrochloric acid. In this video, you can clearly see me mixing together the marble chips and hydrochloric acid and starting my timer. Every 10 seconds then, I'd be writing down the mass of this solution, and I'll be able to see how much mass is lost as that time progresses. For all of these, it's really important, if you're asked to describe the practical, you remember to include a timer and that you're measuring these changes over time. If you don't mention the idea of over time, you're going to miss out on marks on these questions. For example, the first one is timing the reaction, the second one is measuring the volume of gas released over time with a gas syringe, and the final one is measuring the change in mass over time using scale. If we were to plot these reactions onto a graph, we'd end up with something looking like this. In these reactions, we're always going to start off with a reaction happening at its fastest at the beginning of the reaction as those reactants start to mix together. There will be the most of these at the beginning, so most collisions happening, so the quickest reaction at the start here. As those reactants gets used up, the reaction's going to slowly slow down, and we'll know that by the steepness of our graph getting less steep and less steep and less steep, till eventually the reaction finishes and we end up with a flat line. To measure the rate of reaction using our graphs, you should calculate the gradient of a line. If it's straight, you can just calculate the gradient by doing the change in y divided by the change in x. If we have got a curved line, like we do in most of these reactions, we're going to take a tangent from that line by drawing a line on the curve to try and make it so we can see what angle it's curving at. And we can use the line that we draw, the tangent that we draw, to calculate our rate of reaction from here. This graph describes the reaction when mass is being lost, so it's similar, but we can see that the mass is going down over time instead of going up. We still get starting off steepest at the beginning, and it still flattens off as the reaction goes on, as the reactants are used up. There are two terms you need to be able to talk about when it comes to why rates change. You should be able to understand what a collision is, because for reactions to happen, the particles of each reaction must collide, and they must have enough energy to collide, and that amount of energy we call the activation energy, and they must do it in the right orientation, at the right angle, otherwise reactions are not successful. In all of these situations, the more collisions that are successful, the faster the reaction will be. Now, there are 5 ways that we can affect the rate of a reaction that you need to be able to talk about for your GCSEs. The first one of these is you need to be able to talk about how temperature affects the rate of a reaction. I've put some key points here to do with temperature. We are giving the particles more energy in total. This means they're moving around quicker and colliding more often. Because there's more collisions then, we end up with a faster rate of reaction. As when there's more collisions, more of them will be successful. Importantly, in temperature, there will also, more of these particles are going to have the activation energy, making more of these collisions successful as well. For temperature, everyone forgets the idea of activation energy. You must mention that because they've got more energy, more particles have the activation energy. When it comes to concentration, we are adding more particles into the same volume, making our reaction happen more quickly because the particles are more crowded in the same area. This means because they're more crowded, they will collide more often and the rate of reaction will increase. When it comes to gases, increasing the pressure of a gas has a similar effect as increasing the concentration. We are squashing that gas that would normally be in a specific volume into a smaller volume, making it more crowded, making more collisions with those particles, and so more successful collisions and a faster rate of reaction. Always make sure that you clarify more collisions means a faster rate of reaction. When it comes to using a powder instead of a block of a substance, this means we end up with a higher surface area. The more surface area there is, the more surface there is for collisions to happen with, and we know the more collisions, the faster our rate's going to be. When we use a catalyst, we lower the activation energy of our reaction. If you didn't know, the activation energy is the amount of energy required for a collision to be successful. Activation energy makes this amount lower, so more particles then are going to have successful collisions, making their reactions actually happen. If you have any questions about this, throw them down in the comments and I can go through them. Thanks very much for watching. Make sure you stay safe, stay alert, stay curious, and subscribe.